Welcome back everyone, Corey here again. Today you guys are going to be designing an impulse turbine, so I'm going to take a few minutes to show you how you can do that. In this other window I have up, there's a model of the demo turbine you guys will be looking at. As you can see, there's not too many parts to it. There's a cross section here of a hole to fit the rotating shaft into. Here we have the hub or the runner of the turbine. And then finally the blades or the buckets. These are what are going to catch the water that comes into the inlet that rotates the turbine. So when you make your turbine, you are going to be restricted somewhat in terms of the dimensions. So for the hub, you cannot make its diameter any larger than 30 millimeters, that's 3 centimeters. And from tip to tip, your turbine cannot be any larger than 70 millimeters, so that's 7 centimeters. So just like we did in the bridge activity, we're going to use some construction geometry to inform our sizing. Also, since the shaft is a standard size, this cross section right here, this hole, has to be exactly the same for everyone. I'll show you how to size that in a few moments. So let's go back to our empty part file. And I'm going to start sketching on the top plane. Of course, the first thing we need to do is make our hub. So we're going to use the circle tool, put its center point at the origin, drag it out like so. And now I did say the maximum dimension of its diameter should be 30 millimeters, but you also don't want it to be too small. So I'm going to go with 25 millimeters for my diameter and hit OK. Next, you're going to draw another circle at the center. But this time, you're going to give it a dimension of 6.6 millimeters exactly. And then hit OK. Next, click on this inner circle. And then the options, check the For Construction box. We're going to use this construction circle to create our cross-sectional hole. So make sure you have center rectangle selected. Put its center point at the origin and then drag it out until the vertices of the rectangle are coincident with this construction circle. And you're going to do it once more, like so. Then you're going to use the Smart Dimension tool yet again. Give this rectangle a width 3 millimeters. And then give this rectangle a height of 3 millimeters. And then finally, what you'll do is use the Trim Entities tool and get rid of all of these inner lines here so that we can just have a cross for our fully enclosed shape. And then we can hit OK. Now we have the shape that we need to extrude to form the hub of our turbine. If we look back at this demo turbine, we need this hub to be a certain height in order to accommodate our blades, but it also can't be too large so that it doesn't fit into our housing. So I'm going to use this measure tool just to see how tall this hub is. So it's telling me that the center distance is 10 millimeters. That means, of course, that this hub is 1 centimeter tall. We don't want it to be any taller than that, otherwise it's going to cause problems for us in the testing stage. So when I go here and use the extrusion tool in my features tab, I'm going to select the default 10 millimeters and hit OK. And so now we have the main portion of our turbine, the hub or the runner. If you notice, in this demo turbine there are some rounded edges just to give everything a more finished look. You can apply those if you want, you don't have to, but I'll show you how to do it. So in the features tab, you're going to select this tool that says fillet. And here there'll be a box that says items to fillet. We want to fillet these edges, so I'll select this and this. Now our preview is not showing up because currently the fillets can't be carried out successfully. Why? Because we have the radius or the radii of those fillets set to 10 millimeters. That is simply far too large. 10 millimeters is the entire height of our hub. So I'm going to set it to something more reasonable, like 1 millimeter. We can see that turns out pretty fine. So I'm going to stick with that. And so just like that, we have a fully finished hub. Next, I'm going to show you guys how to make these blades. Now, to make our blades, we'll need to construct some reference planes. But before we do that, let's insert some construction geometry. So I'm going to sketch on this face and place a circle. And give that circle a diameter of 70 millimeters. Then I'll convert the circle to construction geometry and exit the sketch. So what we have now is a rough visual representation of how large our blades can be relative to our turbine hub. I'm going to go over to the front plane and I'm going to insert a center line. I want the center line to be horizontal, and I also want it to be in the middle of my hub. So I'm going to use the smart dimension tool to set the distance between that line and either of the faces of the hub to 5 millimeters. I'll then press OK and exit the sketch. Next, we're going to use our trusty reference geometry tool. So we're going to make a plane that is coincident with this sketch and parallel with the top plane. Then we're going to make a few reference planes that are parallel to the front plane. So I want this plane to actually intersect this model we currently have, so I'm going to reduce that distance from 33 down to like 10. Hit OK. Then I will create another plane using the front plane as a reference again, and I will set that offset distance to 25. Finally, I'll make one more plane using the front plane as a reference again, and I will set that distance to just a shade under 35 millimeters. So 33 should work. And so as you can see, that plane isn't quite touching the outer edge of our construction circle. That's what we want. We're going to use all of these planes to make some curves that we will then use to construct a surface, and that surface will act as our blade. So let's start by sketching on plane 2. Gonna look at it head on. And I'll use a style spline. You can use a regular spline if you want to. Hit escape when you're done. And I'm going to set this line to be vertical. That will just ensure that when I perform my mirror, everything will be everything will transition well. You can use these points, these vertices, to control the shape of your spline a bit more. Satisfied with that, so I'll hit OK. I'll then hide that plane since we no longer need it and start sketching on plane 3. As our blade extends out in the middle section, it gets deeper. So I want this next spline to be a bit more exaggerated. That should be good. Again, setting this relationship to vertical and controlling the shape of my spline with these points. You can hit OK and exit that sketch. Now obviously at the end of the blade there's nothing, but we shouldn't use a point to create our last profile, because that can create problems down the line when we're trying to make a surface. So what we can do is extend our blade out near to the tip but not at the tip. So we'll sketch on plane 4, look at it head on, and insert one more curve that's just significantly smaller than these two, but not too small so as to cause us problems when we're creating the geometry we want. One more time, setting this relationship to vertical and editing a little bit with these control points. You can hit OK and exit that sketch. So now we have our 3 curves that can act as profiles for us to create either a boundary surface or a lofted surface. I'm going to show you the lofted surface. So on the profiles we can select these 3 sketches and a yellow preview will be generated to show you how that half of our blade would look. Please note that in order for that preview to be generated, these green dots all have to be virtually within the same plane. Like if this was shifted up here, the preview would not come up. So just keep note of that. But now I want to use guide curves to influence the shape of this feature a bit more because I'm not quite satisfied. So I'll exit this out and show you how we can do that. I'll introduce you to something new, and that is 3D sketching. So if you go to your sketch tab and click on the arrow beneath the sketch button, you'll see the option to 3D sketch. With this, you can create entities that don't have to be restricted to any planes. The downside with using 3D sketching is that depending on what you make, it can be very hard to control. But when you have 2D drawings like this, which can be used as references, things become easier. So I'm going to use a 3D spline to connect the top points of our 2D curves. Hit escape and we're done. And now because this is a curve that was drawn in 3D, we have to change and edit the shape from different orientations to make sure we have exactly what we want. So if we look at it from the top view, we need to move these control points over a bit to get a more sensible shape. That should work quite fine. We'll do the same thing from the right view. That's not too bad. And then we'll do the same thing from the front view. So now it looks sensible. I'm actually going to go back to the right view and shift this control point up a little bit more because I don't want my blade to be that thin near the hub. Then I'll hit OK. So now I can exit this sketch, and now I can insert another 3D spline to connect the bottom points of our 2D curves. You'll notice next to this pencil there's an XY symbol. By pressing tab, you could actually change the orientation or the plane in which you are drawing your 3D item. So you can exit out of that sketch. And if we go back to our surfaces and select Lofted Surface, you can use these 3 sketches as our profiles yet again and control the shape a bit more with the 3D splines we drew, setting them as guide curves. Once we're satisfied with what we have, we can hit OK. And now we're good to go. So we're 80% there. The next thing we need to do is mirror this surface. So we're going to go to our Features tab and select Mirror. And for the mirror face / plane, we're going to select Plane 1. And under Bodies to Mirror, we're going to select this loft. Don't check the Knit Surfaces option, but do check the Merge Solids. Select OK. And now we have our blade. What you can then do is head over to the Surface tab again. Select this knit icon. And choose to, let's delete that from there. And choose to knit these 2 surfaces together. Also going to select Merge Entities and then hit OK. Now what you'll do is go to the Thickened tab, the Thicken option. Select this Surface Knit 1, and of course 10mm is far too big, that feature wouldn't even propagate. We're going to set this to something more reasonable like 1mm. That seems like that would work. Uncheck this Merge Result option and then hit OK. And so there we have it, one of our turbine blades. Now 1mm actually seems like a bit too much, so I'm gonna edit that feature and bring it down to like 0.6. And that seems more reasonable. Now if this little chip here, so to say, disturbs you, we can do a few things to fill that. So if you come over here to where we have boundary surface, you can select that, and under direction 1 we can choose this edge and this edge. Again, we want these green dots to line up more or less, so we'll shift this one over here. And sometimes when that doesn't work, you just have to delete your selections again. And then choose them over. There you go. You can use some other curves to influence the shape of this boundary surface, just like how you can do with the lofts, but we're not going to go through that now. And next what we can do is choose the filled surface option. So the patch boundaries are essentially edges. You can select this edge, and this edge, and a yellow preview will show up. You can hit OK. And we can do the same thing on this side. So going back to filled surface, select this edge, and this edge. Hit OK. Now that's just an assortment of surfaces, so really it's not completely solid at the tip, but we can change that. So if we enable this section view, that is what that button does. We can drag a plane out that shows us what parts of our object is hollow or not. So if we want to make inside there solid, we can use our knit surfaces command once more and select some faces. So I'm going to select this face, this face, this face, and we also need those two inner faces. So if you want to get to those, you'd have to right click somewhere and go on to select other. And then once you do that, you should be able to get to those. So that's one face selected, and we need one more, the one over here. This one. And so now what you can do is check the create solid option and the merge entities option and hit OK. So now if we bring out this section view tool again, we can see that that part is completely solid. I'm gonna go and hide some of these planes because they are just getting in the way now. And so the last thing you can do oops, that's not what I wanted to do, sorry. The last thing you can do is create a circular pattern out of this blade. So if you go to features and under linear pattern you click the arrow and then you select circular pattern. For the direction we can choose the outer edge of this turbine hub, or rather the outer face I should say, and the direction out of the features and faces. There we go. And for bodies we can choose that thicken as well as this surface knit. Currently the number of instances is set to 15. I think that's fine. If anything, I would reduce that to like 12. Seems more reasonable. And then hit OK. And so now we have our turbine. So that was a tutorial on how you can make your turbines. You could have used more guide curves if you wanted to control how this outer side of the turbine looked. You could have inserted more control points to your 3D splines. You could have done a few things, but really it's all up to you. That was just to show you the basic method on how to make this thing. So good luck, and I hope you all come up with some great designs.